Interaction is about understanding relevance and frequency. My name is Oliver Gerstheimer. Welcome to my HMI Design Masterclass. For a good design, you need to know about the things that are behind, inside, and on top. Just like when we design a kitchen and want to put items in drawers, on shelves, or into the dishwasher, we need a precise logic for what goes where and in what order. Menus are what we should use when we want to create free access to contents that are or should be sorted into different categories. And we can provide guidance for tasks or situations through the menu. Here you can see such a menu labeled with a familiar hamburger icon. It lists our options, A, B, C. We tap on option A, and we get the corresponding content. But I will go back and show you another option. Here you can see a submenu using content tabs as a bottom navigation bar. This follows a similar pattern to a drawer that you can open to access contents sorted into multiple compartments. Back to the screen with the workflow. A workflow is use case specific and based on a decision tree. It contains all the steps in a use case, as you can see here in the content area where we guide the user through the steps, that is, the workflow. We can tap through the steps, and the interface provides feedback as to which step the user is on. Contents can vary, of course. For example, here we have a drop-down field and color options. When we look at the quality level we see in error messages, the central issue is the sheer number of error messages and the basic settings. Users are often faced with too many messages, let's say 1,000 per hour, and only 10 of these are relevant. So again, relevance and frequency are important. Second, the visual design matters as well. Let's look at alerts. This is a bad but typical error message that says, well, I'm in error, and that's it. I get no additional information. All I can do is say, okay, thanks, acknowledged. The first step to improve this is to provide more information and explain the error or its cause to the user. As you can see here, this is telling us what is wrong where, which is good, but the next step is even better. Here we offer two options for user interaction, and the user can either resolve the issue by tapping Configure Now or deal with the issue later. What are the key aspects of good error handling and management? First, messages should be visually assigned to a location, especially in large machines or plants, so that I can see where something is wrong. Second, error messages should not be mere alerts or status reports, but offer a resolution for the situation, or an option to assign a priority to the error to empower the user to handle the situation. And last but not least, do keep in mind that it really pays off to invest in good error management and optimization. I'd rather you spend less on marketing and more on error handling. You'll get better returns. User inputs are a typical task for an HMI. Relevance and frequency, again, largely determine whether we work precisely or get bored, and they define the user experience. Don't leave the user hanging in midair, working with the interface in trial and error mode. Look at this example. We have a 3D workpiece where we can manually set 6 to 8 individual dimensions, and we have to do this optimally from both a user and a production perspective. Okay, let's start. This value is 70 millimeters. I want to change it to 40, and what I get is an immediate input error, which is already a good dialogue between user and machine, but maybe it would have been nice to know this beforehand. So I acknowledge the message, tap again, and set the value to 60, and get the feedback that 60 is accepted. A better option for this situation would be to guide the user by providing a range, integrating intelligence on what are suitable input values into the interface, which we can easily do in a standard process or production environment. For example, by providing a drop-down list with available options, where the user can select a suitable parameter, like I'm doing now. I choose this option here and confirm my selection. so the user cannot make a mistake by entering invalid numbers and instead works more efficiently with a limited list of available options. Don't let the user play tiki-taka and have to go through trial and error without getting feedback. You'll be familiar with this from web interfaces where you get tips or hints. For example, for setting or entering a password. This dialogue occurs daily, and so it is a frequent use case, which you should optimize accordingly to enable good interaction with the HMI and the machine. Let's be honest. Just think about one of those vertical arrays of light switches in your home. How often do you press the wrong switch, even after years? Click errors are also a major, or to be more precise, frequent, issue in HMIs, which we should help avoid. And rather than holding the user accountable, we should improve the interaction so that it is familiar and not prone to mistakes, so that it's part of your daily user experience with the HMI. But what if, like you see here, we have entered values that are not correct? Well, then we can provide a simple delete option so that the user can start fresh. And this is one click. I chose this action from a menu that offered different options. Note that the option has to always be in the same place. One click and all the values are cleared. The next step, there are highly relevant alerts and messages, and I should not misclick in these cases. What we just saw was a simple delete, but we can make such actions safer by requiring a second confirmation, especially when the consequences could be drastic. Ask the user, do you really want to do this? Do you really want to delete this? A piece of advice, create efficient and effective structures, like a back button or Ctrl+Z, that can undo a group of actions. That will save time and make users happy. For a complex machine or plant, or a new HMI design, users will get a training course. That's all well and good, but honestly, after the training sessions you've attended, how many details could you recall 2 or 3 weeks later? See? And that's why we absolutely need to talk about providing user assistance, support, and tutorials. A well-designed HMI should provide immediate help in situations. And we all know this, the eye icon, which gives us context-related information directly on the interface. As an HMI designer, I love to call this the sushi strategy and squirrel tactics. Well, squirrels tend to forget some of the nuts they have buried, but in the HMI course, we always find the information we are looking for because it's right there, right in the corresponding context. Why sushi strategy? Because we serve the information in small bites that are easy to swallow. Another important aspect is the top-down approach in the info box. You should give short, concise recommendations. Do this, do that. This contextual help has to be to the point and help the user make decisions. An ideal piece of context help has no more than 3 lines of text. We should not offer pages taken from the manual in this situation. And again, keep in mind that help and support have to be placed in the right context. Then this will make a real business case. You will have fewer calls to your service hotline when you have good contextual help that transfers the knowledge of your engineers into the HMI. To put it in a nutshell, you can of course offer training courses for your users, but with good HMI design, you don't need bulky manuals or user instructions anymore. What is a good animation? To cut to the chase, here's a tip. Use animations for schematic views of a process or a machine. Keep it simple, keep it pragmatic, keep it precise, and make it so it matches the proportions and structures of the machine so users get clear orientation. For example, here you can see a production process, and now we get a notification that there is something wrong at a specific position. We look at the situation. We get clear information on what is wrong. The temperature is too low in this position, and we can go directly to section 6 in the machine, which we know from the analog production context. Animations work according to Occam's razor. We take all the details out of the machine, screws and so on, and all the textures and surfaces. We start with a precise schematic representation with a perfect localization of fault systems to get this insight into the animated environment. Don't distract yourself with expensive animated visuals that lose their luster within a few weeks, and in the end, do not have the level of precision of abstract representations. This was Unit 5 dealing with interaction, the game of ping pong between HMI and user. You can get the 6 tips in the download PDF, and remember, sushi-eating squirrels are HMI designers' best friends. Hey there. Next time, we'll test our prototype and see if the users give our HMI a thumbs down or a thumbs up.